Swayam Prabha. Digital India. Educated India.
It uses morphological features also. And by now, by listening to the lectures, by your own reading, and through working on the assignment, you probably understood the importance of features and property information coming from lower layers. Now we begin to see the complexity, challenge, and character of natural language processing as we go up in the NLP pipeline. The lower level tasks like morphology, part of speech tagging, chunking, they have to be data driven, okay, and they are amenable to machine learning and data driven techniques. But things become much more grand and much more complex as we take up higher levels of NLP tasks. One can say that machine learning can do a lot of work at the lower levels of part of speech tagging, chunking, morphology. But when we begin to take up higher level NLP tasks, then it has to be a combination of human level intelligence and machine intelligence. Okay, they have to work together. Only machine learning will not do, only linguistics and language phenomena will not do. It has to be a combination. So we'll take up parsing, which produces parse tree. Then we'll take up words and disambiguation and semantic role leveling, which enters into semantics. And then we'll take up sentiment analysis and emotion analysis, which needs pragmatics, which is at the highest level of NLP. Now, we'll first motivate why we need parsing. Before that, the agenda for the week will be understanding why parsing is needed. There are two major types of parsing: constituency and dependency, ambiguity in parsing, classical algorithms for parsing, probabilistic parsing, and neural parsing. So this is the agenda, and we'll need at least 2 weeks to discuss many of these things. Now, when we parse a sentence, like the detective listened with a wooden face, the detective listened with a wooden face, then we pass it through the Stanford parser, which is a probabilistic parser and has been heavily used by the NLP community. So that produces a structure of this kind. This is also sequence level, though it represents a tree. Sorry. The root starts the tree. Then there is this S symbol. S means sentence. Sentence is composed of noun phrase and verb phrase at the next level. The noun phrase itself has children as the and detective. So DT and N. Then the verb phrase has constituents as VBD, listened, preposition phrase, which itself is a subtree with a wooden face, and with a wooden face itself is a chunk where we find DT, JJ, wooden, and face. So these three entities, a wooden face, form a chunk. And with a wooden face is a preposition phrase. Sorry, preposition phrase is not a chunk. A wooden face is a chunk. So you can see this kind of structure emerges. And people for quite some time did not realize about the tree nature, the deep, tree-like nature of information in the sentences. It was due to work by Chomsky and such linguists who worked on what is called generative grammar. They showed that this kind of tree structure and recursivity is at the foundation of parsing. Parsing is a very well-studied problem, not only in NLP, but in linguistics as such. Huge amount of work exists on parsing. And computational linguistics or NLP converts this knowledge into algorithms. So this is one kind of parsing. It is called constituency parsing because there is a rooted tree at S and then there are subtrees below S. One subtree is rooted at NP, noun phrase, another is rooted at VP, word phrase. This is called constituency parsing because the sentence is composed of constituent subtrees and sub-subtrees and sub-sub-subtrees. Okay, so this is composed of subtrees and trees. Another kind of parsing is called dependency parsing, which produces a graph-like structure. This also begins with a root, and here the main entity is the main verb of the sentence. In this sentence, you can see listened is the main verb. And who listened? Detective. So N subj, the subject of the sentence is detective. Detective has a determiner, the detective. That means a particular detective. So DET is linking detective and the. Listen and with, there is a predicate called preposition. Face, a face, again determiner. A mod is adjective modifier, so wooden modifies face. And there is a preposition object which is going with face. So this is called dependency parsing. It uncovers the dependencies in the sentence. Constituency uncovers the trees and subtrees. Dependency uncovers the dependencies. Okay, who depends on what? So this is what we'll elaborate during our discussion on parsing, and we'll see how algorithms try to do this task. Now, the question that we ask is, why do we need parsing? After all, is grammaticality really crucial? Because a child can understand a language, or we also can understand a language, even if we do not know the grammar of the language, if we know the word meanings and the situations. Also, even when people speak ungrammatical sentences, noisy sentences, we understand the meaning. So why, after all, do we need parsing? Okay, we need parsing to have correct associations and dependencies and correct groupings, which is very crucial. So I'll take an example from sentiment analysis and take this sentence here. I love the songs in the movie, though only the cast was liked by my brother. I love the songs in the movie, though only the cast was liked by my brother. So somebody please verify that you're looking at this example. I love the songs.
Yes, sir.
Okay. So if I ask who loved the songs, the answer cannot be my brother, because nothing is said about my brother liking the songs. What is said is that my brother likes the cast, only the cast. And I love the songs. And what did I love? The songs in the movie, not the movie, maybe, totally. And my brother liked the cast, may not be the songs, may not be the movie. So these kind of associations, establishing those linkages is critical for processing of text mining, question answering, information extraction, translation, everywhere. This is very critical. This is called entity relationship. Okay, so establishing entities and the relationships is critical to natural language processing because we are dealing with unstructured text. So from unstructured text, which is a free flow of words, to go to a entity relationship diagram, a kind of graph or a tree of constituents, is critical for natural language processing. Now, for this, we have to look at the definition of sentiment analysis, which will be taken up in more detail. But the definition itself, you can see, conceals the requirement for parsing. That in the definition itself, we do see the existence of requirement for parsing. So sentiment analysis is defined by a tuple. What is the sentiment analysis problem? Given the text, find out if the sentiment expressed is positive or negative. This is a basic task and very crucial to our life. So this movie was good, expresses positive sentiment. But the songs were bad, that expresses a negative sentiment. This movie had Amir Khan in the lead role. This is a neutral sentence. It doesn't have any positive or negative sentiment. It is stating an objective fact. So this is a 5 tuple. The third entity is the most important entity here. S is the sentiment. And the sentiment about E, the entity, about a particular aspect of the entity, A, the sentiment is held by H, the opinion holder, and at a particular time, T. So all these are important components in defining sentiment analysis. Because the opinion changes from person to person, that's why H is important. Opinion changes from time to time. I like the Samsung phone today. Tomorrow I like maybe a different phone. Okay, so the sentiment changes from time to time. That's why T. The sentiment itself takes a value of positive, negative, and neutral, S. And A is important because I'm interested in a particular aspect of the entity. So A of E. So EI is the entity, ith entity, the jth aspect of ith entity, so Aij, HK kth opinion holder, L at lth time, and Sijkl is the sentiment expressed by kth opinion holder at time L on the aspect J of entity I. So that's why Sijkl. So since there are these I, J, K, L as indexes, we need to identify those entities from the text. And that's why when I have this sentence, I love the songs in the movie, though only the cast was liked by my brother, I have to isolate the pairs. The entity is movie. Aspects of movie are song and cast. Opinion holders are I and my brother. The time is present for I and past for my brother. He liked the cast. Therefore, opinion, sentiment, aspect, triple, okay, which is a structure emerging from the unstructured text, is I love song, brother like cast. Okay, so this is the opinion, sentiment, aspect, triple, which is critical for sentiment analysis and proper association of sentiment on a particular aspect to a particular opinion holder. Okay, you cannot do any kind of confusion there because then the question, answer, sentiment, etc. will be wrong, and the downstream NLP application also will be wrong. The error percolates. So we have already mentioned there are two kinds of parse representations, constituency and dependency. I'm sorry, the arcs should have been placed properly. So there is a left arc going from S to NP and right arc going from S to VP. Maybe the arcs are not very easily visible to you, but this is the structure. I'll make this correction. In dependency parsing, you get dependency tree where the main verb is the central entity. The left arc is going to arguments and right arc is going to adjuncts. So arguments are essential entities, adjuncts are additional information. Now, dependency approach, the parsing which produces entities and the relationships at the shallow level, is suitable for free word order languages. So we know that Indian languages are free word order. Ram ne Sham ko dekha, Sham ko Ram ne dekha, both are fine. But English relies on the position of the word with respect to verb to know who is the subject and who is the object. Ram ne Sham ko dekha, the subject is Ram because of ne, and Sham ko, Sham is object because of ko. Since these markers are sitting on the words, I can take liberty with their ordering. I can place them anywhere, but still the meaning will be conveyed. But when I say Ram saw Sham, I cannot take liberty with the word order because then the meaning will change. If I juxtapose, interchange the position of Ram and Sham, then Sham becomes agent, Ram becomes object. Sham saw Ram. Here the seer is Sham, the object seen is Ram. So English has to rely on word order to convey meaning accurately. That's why English is called a fixed word order language, and Hindi is a free word order language. Though of course there are gray areas and it is a spectrum. English is towards fixed order, Hindi is towards flexible order, because we know that we can change the normal order to express a special situation. For example, to express emphasis. Okay, Ram saw Sham. It is Sham that Ram saw. You see, now Sham has come to the front. It is Sham that Ram saw. So the normal order is called canonical order. They have the highest frequency in the corpus. When we want to give emphasis or bring out something special in the meaning, we temper the word of the language, order of the word. And the most sensitive positions in a sentence are its front and the back. Okay, when we place entities in the front or the back, we attract attention to those positions and they increase in their importance. Okay, so so the canonical order is the most frequent order, but changing the order of the word to bring them to the front and back is done to focus emphasis on entities. So dependency parsing is really one step closer to semantics, which deals with meaning. Proceeding further, what is challenging about parsing? So we understood the importance of parsing. It is required to group entities and find relationships between them. What is the actual challenge of parsing? Okay, why is it not a trivial and easy problem? The reason for that is what is called structural ambiguity. Now, structural ambiguity means it produces multiple parse trees. So here is a tree corresponding to the sentence, I saw a boy with a telescope. Now you should get used to reading a parse tree and seeing the underlying structure even when the sentence is linear. So when you traverse the tree leaf to leaf, you get the sentence, I saw a boy with a telescope. Now a telescope can be grouped to give the chunk. So DT and N, a telescope produces a chunk and then it produces an NP, the noun phrase. With a telescope, that is a preposition and a noun phrase together, produces PP, a preposition phrase. Now again a chunk and then a noun phrase, a boy, going to the noun phrase. A boy with a telescope. So here you have DT, N and PP, that combination giving rise to NP, noun phrase. We saw, and the whole noun phrase, a boy with a telescope, is giving rise to a verb phrase, PP. And then I is a noun, actually a pronoun, that is giving rise to a noun phrase. And this could be a full noun phrase. The little boy saw a boy with a telescope. So here you have this structure. So you see, this is very important to absorb right in the beginning. How from the words by grouping we go on getting bigger and bigger constituents, and all the constituents are finally merged to give S, the start symbol or the sentence symbol. What we did just now is bottom-up parsing. Okay, we looked at the words and their part of speech and then chunked them and then phrased them and combine phrases to give bigger phrases, and finally S. So, I'm re-emphasizing an important point. A linear sentence has this underlying tree, and the tree is composed of subtrees which are called constituents. So we should be comfortable with a tree underlying a sentence, and we should be comfortable obtaining a sentence from the tree, from the leaves. This is giving me a parse tree for the sentence, I saw a boy with a telescope. It turns out that another parse tree is possible, and that is given here. Here also I is an NP and saw is the verb. A boy with a telescope. So here a boy and with a telescope are at the same level. Okay, they are at the same level under the VP parent, V, NP and PP. Whereas in the previous parse tree, the PP was at a deeper level than V. Okay, V has a sibling NP. NP contains the PP, the preposition phrase. So this indicates something. This indicates a change in meaning. So you see here, a boy with a telescope is more closely bound together. Whereas in this case, a boy with a telescope and verb all are merged together, being bound more closely. So this gives an indication that this activity of seeing was performed with a telescope, the preposition phrase, and the activity resulted in seeing the boy. So seeing, the object of seeing and the instrument of seeing are at the same level, making up that verb activity of seeing. And who saw this? I. So since verb, the object of the verb and the instrument of the verb are at the same level, this means that I had the telescope. Okay, I had used the telescope to see the boy. Whereas since this verb is at a higher level than with a telescope, and since with the telescope is closer to the boy, that means that the boy had the telescope, not me. So this is a very classic sentence from linguistics. I saw a boy with a telescope. It has two meanings depending on who has the telescope. And it is not clear. It is impossible to disambiguate this sentence. By looking at the sentence, you cannot tell who has the telescope, I or the boy. Therefore, at the level of parsing, you have to produce both the outputs. You have to give both the trees, and you cannot do anything further. Okay, so the challenge of parsing comes from ambiguity, like all other layers of natural language processing. And you have already encountered ambiguity and resolved it at the part of speech tagging level, and even at the morphological level. Everywhere you have encountered ambiguity. I will in particular remind you that in part of speech tagging, you got ambiguity when you saw that a word can have multiple parts of speech from the dictionary. Okay, I bank on you, that means I depend on you. Here bank has the part of speech of verb, though bank normally is noun. Okay, so part of speech tag ambiguity was resolved by using probability, hidden Markov model. Chunk also can have ambiguity. Okay, and how the grouping of the word can be ambiguous is again dictated by the underlying meaning. And let me leave this as an exercise for you to find example of a chunk, example of a sentence where the chunking itself is ambiguous. You are seeing the example of parsing facing the challenge of ambiguity. Chunking also has ambiguity. And since you're doing the chunking assignment, the ambiguity is in the form of, at this position, what chunk label should I put, B or I? At a particular position, should I put B or I? Okay, so if I take for example, the red, rigid, rolling round ball. Jyotsna, can you take this example and make a slide out of it? The red, rigid rolling round ball. The red, rigid, rolling round ball. A string of adjectives before ball, and before that a determiner the. Okay, the red, rigid, rolling round ball. Now, surely at rolling, if part of speech tagging was not done, rolling can be a verb. Okay, something that is rolling, so that's a verb. And if there is a verb, most likely it will begin a new chunk. So at this position, surely you will have to decide whether you should put I or B. The correct chunk is I. The whole thing is a chunk. So only the is B. Red, rigid, rolling, round, all of them are I. Ball is also I. Okay. So chunking also has to solve this decision problem of B or I at any position. So here is a classic example of ambiguity where you have two parse trees, and the challenge is to pick up that parse tree which is most appropriate in the current situation, because from parse tree I'll do semantics, pragmatics, sentiment analysis, question answering, and so on and so forth, machine translation. So all large NLP applications depend on goodness of parsing. I saw the boy with the telescope also shows ambiguity for dependency parsing. So see, here is the main verb saw. The agent is I, object is boy, and boy is modified with a telescope. So the boy is modified, a particular boy who has a telescope. So in this case, the dependency parse tree shows that the boy has a telescope. But if I have another dependency parse tree, saw agent is I, object is boy, and saw is modified with a telescope. Here the modifier is an instrument. So I am using the telescope. Here I have the telescope, as is clear from the dependency parse tree. So you can see that the parse tree is a more definite information compared to the raw sentence. So that's why the parse tree has to resolve ambiguity and give multiple outputs if that is the requirement, that is what is possible in that situation. So we would like to say that a raw sentence has high entropy, a parsed sentence has lower entropy. A raw sentence has high entropy, morphologically processed sentence has little lower entropy, part of speech tagged sentence has still lower entropy, chunked sentence has still lower entropy, parsed sentence has much lower entropy. At semantics level, when you have identified semantic roles and have done disambiguation of words, it has very low entropy. Okay, so at every layer we are reducing uncertainty, or we are lowering the entropy, and we are increasing more definite and concrete information. But what is the price? The price is a lot of processing, a lot of data, a lot of rules created by human beings, a lot of machine learning time and space, storage and processing, GPU, CPU, okay, word embeddings, GPT-3, BART, and so on. All this is the investment. And in spite of all these, you may not be able to resolve ambiguity and have to produce multiple outputs. And if the question is what is better, dependency or constituency, both are important, but dependency seems to be more important for free word order languages and also for capturing semantic relations. Now, there are two views of NLP. This is one is called verb-centric view, the other is called noun-centric view. Now, information retrieval, which is using a lot of AI NLP these days, because you want more and more intelligent search engine. And this particular course has a web component where we would like to look at information retrieval also from the point of view of NLP. In information retrieval, the important activity is performed by nouns. Okay, the capital of India, if you give this as a query to Google search engine, then what is important is capital. India. These are important. So these are noun entities. So information retrieval requires giving importance to nouns. On the other hand, question answering, we'll have to give a lot of importance to the main verb of the sentence. Okay, so the main verb has relationship with other nouns in the form of agent, who is doing the activity, object, what is being done, place, where is being done, time, when is it being done, instrument, by what is the activity being performed, source, if it is a moving activity, from where, destination, going to where. Okay, so all these are relationships of the verb with the nouns. Let me just verify that you are seeing verb centric view of the sentence. Can somebody verify?
Yes, sir.
Yes, sir. Yeah, okay. So this is very fundamental to our understanding of the world through language. Okay, who is doing, what is being done, where is being done, when was it being done, by what, from where, to where. These are called WH entities. Okay, WH questions. And if you have heard some wise statements, okay, some wise person has said that I have these friends with me wherever I go. Who are these friends? These friends are who, what, where, when, by what, from where, to where. They are always with me wherever I go. Some wise man has said. I don't know if it is Socrates or Plato or somebody. So these are the critical relationships which uncover the fundamental information in a sentence. And this is what the entity relationships target. Information extraction targets those things, those entities. And these are nouns, they are linked with the verb. And these relationships like agent, object, place, time, instrument, source, destination, these are called semantic roles or case roles. Okay, and if you remember your grammar from school days, these are called karakas. Karakas, karma karak, karta karak, karan karak, sampradhan karak, adhikaran karak. Okay, adhikaran again is of two kinds, kal adhikaran and sthan adhikaran. Okay, so Jyotsna, please put a slide on karaks. Okay, karta, karm, karan, sampradhan, apadan, adhikaran. Adhikaran two kinds, sthan and kal. Apadan is source. So elaborate work and thinking has gone behind case relations, the karak relations, both in Indian tradition and Western tradition. Okay, because they identify the relationship of words with the main verb, and main verb is at the center stage here. So you can look upon the whole sentence as a dramatic stage where the actors are the semantic role linked nouns. Okay, and the action is the verb. So all these is possible if you can do parsing accurately. Okay, and parsing is possible if you do part of speech tagging accurately. And chunking, part of speech tagging depend on morphological information, primarily to make the processing more efficient, primarily to reduce the data requirement, and also primarily to deal with data sparsity, unseen words. Okay, so somebody asked a question on fragmentation. I answered it in the WhatsApp group, which was also placed in MS Teams and Moodle. Fragmentation means breaking a chunk into smaller parts mistakenly. Okay, and hidden Markov models can lead to fragmentation because of wrong decision. Maximum entropy Markov models are a better place to eliminate or reduce fragmentation because they have more information. They depend on part of speech, morphological features, other properties, so they're more robust with respect to chunking error. Okay, because they're using more information. So here is a diagram which shows the semantic relations in a sentence which captures everything: who, where, which, when, and so on. Ram reads a book with his glasses in the evening in his study. So this is a very nice example, and we would like to spend a little time on this. because it illustrates many things about language. So the center stage is read, the main verb. When was the reading performed? In the evening. So time relation. The reading was done by whom? Ram, agent relation. What did he read? A book, object relation. And by what did he read? Using the glasses, so instrument. And where did he read? Study room, place relation. So see agent, object, instrument, place and time. Okay, so these are foundational semantic relations. However, they are not enough. Just like in part of speech tagging, just noun, verb, adjective, adverb, preposition, conjunction, exclamation is not enough. Though this is foundational, you have to do them accurately. They need refinements. So you have to distinguish between proper noun and common noun. In common noun, you have to distinguish between abstract noun and concrete noun. In concrete noun, you have to distinguish between living nouns and non-living nouns. In living nouns, you have to distinguish between animals and plants. In animal, between carnivorous and herbivorous. So see, gradually a taxonomy develops where the semantics becomes more and more refined. So such information is captured in knowledge graphs, in things like WordNet, which I'll cover in semantics. And we have made a lot of contribution to WordNet from our lab in IIT Bombay, creating 18 languages WordNets, all are linked together. Okay, so this is the graph that you obtained, the semantic graph or the meaning graph from the sentence. Now note that the property of the word also becomes important. So Ram reads a book in his class in the evening. Evening is preceded by in the, and study also could have been preceded by in the. Okay, so the system could have confused to give time relationship to study and place relationship to evening. Okay, place can go to evening and time to study. So and the reason is that in the is same, the preposition is same. So the same thing can happen for Hindi also. Okay, Adhyan Kaksha Me, Sham Ko. Of course, there I have a different marker, Sham Ko. But if it is Dophar Me, at noon, okay, Adhyan Kaksha Me, Dophar Me. Then again you have Me as the postposition. Adhyan Kaksh Mein, Dophar Mein. So it is same Mein. So why should Adhyan Kaksh get time relation, place relation, and Dophar get time relation? Why? The reason is that these words have different properties. Okay, Adhyan Kaksha cannot be the target of a time relation. Okay, it is not a time entity. Similarly, Dophar Mein in the evening. Evening is not a place entity. Okay, though they are taking the same postposition and preposition. So you'll have to disambiguate that when you create this kind of semantic role levels or even dependency levels, which is shallower. Okay, so we need to know the properties of the words. They come from things like WordNet, VerbNet, which are knowledge graphs. They also are encoded in the word vectors. Okay, the vector of study and the vector of evening, they will be different, and there will be a component which I cannot read because vectors lack interpretability, explainability. I cannot read those components and I cannot associate components with a particular semantics. When I look at the components, there will be some indication, some clue in the word vector, which shows that evening is a time noun, study is a place noun. Okay, the properties are encoded there. So to get these arrows correctly and to label them correctly is disambiguation work needing a lot of data, a lot of rules, either in knowledge-based system or in machine learning-based system or a hybrid system which combines both. So let us remember that again we have to face a challenging problem of disambiguation. So this is a nice representation of the meaning content in the sentence. And here the correct relations are agent, karta, object, karma, instrument, karan, place, sthan adhikaran, time, kal adhikaran. Okay, so these are the correct relations from Indian tradition and case markers from Western tradition. Another important thing to note here is that not all these words have the same level of quote unquote importance. What do I mean by importance? Some entities are critical for the sentence to be existing even. Okay, so if you say Ram reads, implicitly there is an expectation for what is he reading. So Ram reads a book, and here I can finish the sentence and put a full stop. So reads a book is not complete. Who is reading is needed, and Ram reads is again not complete because what is being read by Ram is important. So this critical information, a book and Ram are agent and object. Agent and object are critical for reads. So this is a property of the verb reads, that it requires an agent and requires an object. Okay, so we call object and agent as essential requirements of read, and we call them arguments. Okay, we call them arguments. So remember this term, we call them arguments. We'll face them or encounter them later also. So a book is satisfying the object argument requirement for read. Ram is satisfying the agent requirement for read. So the essential nouns which are required to establish the sentence are called arguments. This additional information with his glasses in the evening in the study, these are additional information. Without them also the sentence can be completed. You can put a full stop after that. But these bring additional information and they're called adjuncts. So let us remember these two terms, arguments and adjuncts. Okay, so Jyotsna kindly put a slide here after this, isolating the adjuncts from the arguments. Okay, so arguments are Ram and book, and adjuncts are glasses, evening and study. What is linking the objects and arguments with the main verb are these determiners, prepositions, etc., which are called function words. They are called function words because they link the content words, the meaning bearing, information bearing words. So we have understood important things here, the case relationships, the adjuncts and the arguments. Another important information that was conveyed is that evening cannot have the place relationship, study cannot have the time relationship. So this is called deservingness. Okay, deservingness. So read has a desire for finding the time relationship entity and the place relationship entity. In the Sanskrit tradition, Indian linguistic tradition, this is called akanksha. Jyotsna, please put this point here. Akanksha or desire. The verbs have desire and the nouns fulfill that desire, but only particular kinds of noun. So that particular kinds of noun or the suitability of the noun to fulfill that desire is called the deservingness. This is also in Indian tradition, it is called yogyata, deservingness. Okay, akanksha and yogyata, they go together. And we also, in Western linguistics, we call this selectional preference. So please write this term, Jyotsna. Selectional preference. That means the word study gets selectional preference over evening. Okay, study gets selectional preference over evening when it comes to place relationship, because study has the property of satisfying that desire. Now, this kind of discussion, which goes into the nitty-gritties of word properties, there may be a stand saying that, do we need all this? I mean, you give a huge amount of data to a deep learning system, and you will get all these semantic roles. Why this, splitting the hair and doing nitpicking? Okay, what is the need for all that? It turns out that as you go higher up in the NLP stack, okay, take up more and more complex NLP tasks, only data is not sufficient. Okay, you have to support the data with this kind of linguistic insight, and only linguistic insight is also not enough, because linguistic rule-based systems lack robustness. There are many cases which are left out because you have not formed the rules for them, And even if you form the rules can conflict with each other. You have to give a probability value or the weight value of which rule should take precedence over another rule. Okay, so you need those kind of probability values and certainty weights. They come from data. But only data is not enough, because the data cannot capture the complexity and the richness of language totally. You will have to bring in linguistics there. So all these ideas about akanksha, yogyata, semantic roles, time, place, agent, object, instrument, they're very critical. Once we know them and make them as machine learning labels, okay, time, place, agent, object, instrument are 5 class levels. So once we have decided on the levels, we have cast them as a classification problem in machine learning, then you need data. Okay, so the problem formulation itself needs a lot of insight into how language operates. So now we'll go to parsing algorithm, but at this point of time, some announcements, some questions, because we have about 10 minutes left. So let me take the questions. Before that, quick announcements, which Diptesh will elaborate later, is that we'll have a quiz for you next week. Okay, a 30 minutes quiz. That quiz will be multiple choice question. You must have got the intimation of this in Moodle, Teams, and WhatsApp. Okay, so there will be quiz, and this Sunday afternoon we'll have discussion with you to assess progress on the assignments, and we'll also have discussions on your projects. What project will you do in the semester? And projects you should really pick up by looking at the NLP pipeline or the stack. You should pick up problems from higher levels of NLP task to do a project. For example, you can do a chatbot. For example, you can create a chatbot. So there are many chatbots, but chatbots always throw up new challenges. So you can take up a particular chatbot in a specific domain with a particular ability. So we have done, for example, work on polite chatbots whose responses are always polite. Okay, we have done work on sarcastic chatbot. That means chatbots which always produce sarcastic statements as response, but they also understand sarcasm. Okay, so then you can have multimodal chatbot. So the chatbot looks at the picture and does question answering. Okay, so chatbot itself is a very rich area, which is a bigger umbrella of human-computer interaction. Okay, or you could work, for example, with on machine translation. I have not mentioned machine translation with respect to this pipeline anywhere, because machine translation really is the mother of natural language processing. Just like natural language processing is called the mother of artificial intelligence itself, because it contains in itself everything of AI. It contains reasoning, it contains entailment, it contains translation, it contains things like compilation. Okay, it requires big architecture, it requires speed. So NLP requires everything that AI also wants, and machine translation wants the whole pipeline, starting from morphology, goes up to discourse and co-reference. So machine translation is the mother of all problems in NLP. So you can pick up a project on machine translation, for example. For example, you might want to translate only commands, not the full language, but only commands. What kind of commands and what kind of questions? Things that a tourist asks when he or she goes to a new country. So this is called the survival kit question answering system. But the tourist asks in his or her own language, and the chatbot gets the answer and produces the answer in the own language, which goes through both question answering and machine translation. Now, when I'm mentioning machine translation, I'm tempted to show you one thing. Is my screen still visible? Is my screen visible?
Yes, sir.
Can you see this Microsoft Translation Teams ongoing mission? Do you see this here on the screen? Yeah. Okay. So Microsoft has created recently a translation system for low resource languages. So Indian languages particularly, involving Oriya, Bengali, then Marathi, Punjabi, Gujarati, Malayalam, Kannada. So all these are low resource languages. That means they do not have huge amount of parallel corpus to train the machine. And the person who is contributing a lot on this is my student Anup, who was in CFILT, who did his PhD in CFILT, and has been always working on low resource related languages machine translation. So let me show you an output which I tried to the morning. And this is from one of the student feedback. I'm very interested in natural language processing, and as I spent most of the time in reading the extra reference materials attached by the professor and TA. Some of the papers are quite overwhelming and we find it difficult to understand. It would be really helpful if some necessary primers required for understanding a particular paper is also attached nearby. Okay, so this is the comment given by one of you, and I was seeing how does the Bing translator, which has been announced recently, which Anup has contributed a lot, how is it performing? So look at the Hindi translation. मैं प्राकृतिक भाषा प्रसंस्करण. So this is natural language processing. मैं बहुत रुचि रखता हूँ और इस प्रकार मैंने प्रोफेसर और टीए द्वारा संलग्न अतिरिक्त संदर्भ सामग्रियों को पढ़ने में अधिकांश समय बिताया. Not a bad sentence altogether. Pretty good, right? Professor or TA द्वारा संलग्न. Attached. Though attached is not a completely correct word here. So the Hindi translation came out as संलग्न अतिरिक्त संदर्भ सामग्री. अतिरिक्त संदर्भ सामग्रियों is extra reference material. So this is chunking, extra reference materials. And the chunk is converted to Hindi also, in Hindi chunk, अतिरिक्त संदर्भ सामग्रियों. You see the plural marker here, materials को पढ़ने में अधिकांश समय बिताया. कुछ पेपर काफी भारी होते हैं. भारी is overwhelming, though it means complexity, and maybe the word choice is not accurate. होते हैं और हमें समझना मुश्किल लगता है. Not bad. The sentence is not completely idiomatic. A Hindi speaker will maybe raise eyebrows, but the meaning is transferred. यह वास्तव में उपयोगी होगा अगर कुछ आवश्यक एक विशेष कागज को समझने के लिए आवश्यक प्राइमर भी पास से जुड़ा हुआ है. You get the meaning approximately, but begin to see that there is some cluttering of syntax and semantics. So here, for example, some material on generative models. उदाहरण के लिए generative model has been transliterated. It is not being translated. जैसे अधिकतम entropy Markov model. Entropy Markov model is transliterated, but maximum has been translated at अधिकतम, okay, which is not really appropriate. So this kind of transliteration disambiguity also is a challenge everywhere. और CRF जैसे कुछ भेदभावपूर्ण is coming from discriminative. Really, this word is not correct here. भेदभावपूर्ण, okay, has a different meaning. Graphical model is okay for kuch samagri. So this is how it came out. And for a curiosity, maybe we can paste this in Google and see how it performs in terms of translation. Google Translation also has become very good these days through a lot of data. Okay, and it used to be quite pathetic, many years before. Okay, so let's do English Hindi. Let me enter the text here. So this is the Google output. मुझे प्राकृतिक भाषा प्रसंस्करण में बहुत दिलचस्पी है. What did Bing say? Bing said, बहुत रुचि रखता हूँ. See how the same thing is said in two different ways by Bing and Google. मुझे प्राकृतिक भाषा प्रसंस्करण में बहुत दिलचस्पी है और इस प्रकार मैंने प्रोफेसर और टीए द्वारा संलग्न अतिरिक्त संदर्भ सामग्री को पढ़ने में ज़्यादातर समय बिताया है. कुछ पेपर काफ़ी अटपटे होते हैं. So you see, this is not translated as भारी. Google is taking this as कुछ पेपर काफ़ी अटपटे होते हैं और हमें समझना मुश्किल हो जाता है. Much better quality. This is called more fluent. यदि किसी विशेष पेपर को समझने के लिए आवश्यक कुछ प्राइमरों को पास में संलग्न किया गया है तो यह वास्तव में सहायक होगा. This is also okay. The Bing translate is little hesitant, little scrappy. उदाहरण के लिए जेनेरिक मॉडल पर जेनरेटिव को जेनेरिक बना दिया, कुछ सामग्री जैसे कि अधिकतम एंट्रोपी मार्कअप मॉडल और कुछ भेदभावपूर्ण, दिस आर आल्सो ट्रांसलेटिंग discriminative as भेदभावपूर्ण. So you see, so this is quite good. Machine is almost there, though there will be some post editing required by the human being. So machine translation is really the epitome of natural language processing, involving pause tagging, named entity, semantic role, chunking, everything. Okay, so you can choose a project in machine translation also, and all this I'm happy about, because here people from our lab who have done their research in our lab are actually directly involved, contributing to all this work, which gives a nice feeling. In fact, Google's transliteration is the first level of transliteration was created by a student from our lab called Anupama, who is a very senior researcher now, I hope, in Google. Okay, so many of these Indian language technology contributions have come from our lab, and it feels happy. Okay,
Sure.
thank you.
Thank you, sir. Thank you so much.